Okay, finishing up chapter 7, we're going to talk about identifying types of symmetry on the Cartesian plane. Learning outcome, same as last lesson, to demonstrate an understanding of line and rotational symmetry. Okay, so a diagram of a shape and its transformation image may have line symmetry, rotational symmetry, both, or none. Okay, so transformation just means that it's been reflected or turned. Okay, reflected meaning flipped over a line, so this ended up over here. Or turned means put your dot in the center and then turn it on itself. So the diagram of the shape and its transformation. So the original and the new may have line symmetry. It may have rotational symmetry. Lots of times it has both, but it could have none. Okay, so let's take a look at this example number 1, which is very easy. It says our rectangles ABCD and EFGH related by symmetry. Hopefully you're thinking to yourself, well, yeah, it is, and the line of symmetry is right here. So you could easily show that A, B, C, and D has been reflected over this line. If you want to call it L1 for line 1, you could say that A, B, C, D is reflected over line 1 to become EFGH. And a quick way to check. Look at how B is 1 space away from the line. E is 1 space from the line. A is 1, 2, 3, 4, 5, 6 away. 1, 2, 3, 4, 5, 6 gets me to F. And then D and C, H and G will be exactly the same. Okay? You could not, however, say that it's got this symmetry. Okay? Clearly, this shape has nothing to do with this shape over that line that I just drew. And in terms of rotational symmetry, what do you think about that? Hold on, delete. Let's get rid of this. Could you say that there is any rotational symmetry from ABCD to EFG? So let me show you something. Kind of cool. Let's go back to my skinny line. Let's trace A. Oops, that didn't work. Try it again. A to B, B to C, C to D, and D to A. I'm just tracing over top so I can get that shape. Oh, and I want a dot. But I'm not going to put the dot on the shape because clearly it's not rotating on itself. But what if I stick a dot right here? Okay. And then I'm going to join all of these and make it one shape. Do you think, rotation-wise, keep in mind that it's rotating about that dot. Okay, I can't do this with the smartboard, but I want you to think about that dot staying there and this shape going this way. So I'm going to rotate it. Oops. And remember, that dot would have to be there. Okay, it actually has rotational symmetry of 180 degrees because I could turn this way or this way, either way, 180 degrees, and it would be on top of itself. So I could also say it has rotational symmetry, order 2. Okay, so press pause, you give it a try, and then see if you get A correct. Okay, so it says for each diagram, find out if the polygons are related by symmetry. So first of all, number A, here it says, do the polygons face opposite ways? So if you struggle to see it, take your pencil and go over top, just so you can see. There's my original, and there's my other one. Okay, I'm not doing a very good job tracing it, but you get the point. So, do they face opposite ways? Sure do. One polygon is above the other, so try a horizontal line of reflection. So if I drew a line of reflection exactly in the middle of each two, would you agree that this flipped on to itself this way? So this point flipped over the line, becoming this point. This point flipped over the line to become there. This one became that one. This one became that one. Okay, are the polygons related by reflection? Yes. If they are, draw the line of reflection. I've done that. So they have line symmetry. Now, do the polygons touch? No. So try a point of rotation, blank the polygons. I think they probably mean in between. So let's get rid of all this stuff. It's kind of like the last example I just showed you. If I put a line or a point of rotation right here, can you visualize that either 180 degrees clockwise or 180 degrees clockwise, I could turn this self, if I stick my pencil here, and we're talking this shape here, can you visualize that I would be able to stick my pencil here and turn this so that this ended up here? Okay, so try a point of rotation between, I think, is maybe what they want here. Try different points. And yes, they did match. So yes, they were. So they could be, they have rotational symmetry, order 2, and this would be the point of symmetry. Okay, so make sure you check line and rotation. All right, now B, little bit different. Let's see. I need a skinny line. Let's do green. I can't really see them. I'm going to just trace over them so they're easier to visualize. And you may want to use that strategy as well. When you use graph paper, it helps you so you can draw them, but sometimes it's not so easy to see. And I'll use purple for this one. There we go. Okay, now, the first question says, do the polygons face different ways? Yeah, they do. Okay, do they face opposite ways? I would say no, they don't face opposite ways. This one's down and this one's to the right. Those aren't opposite of each other. So are the polygons related by reflection? I would say no. It's not like this one got flipped over a line anywhere that you could draw. Now, did they touch? Nope. So try a point rotation between. Do you think that there's anywhere we can stick a dot or we could turn this? Like, look at how this ended up here. I don't really see any point where you could stick a point and turn this piece of paper. If this were on paper, this would end up there. So do they ever match? No. No, no rotational symmetry. So they're exact copies of each other, but they don't necessarily have symmetry. Okay? They're not related in that sense. Okay, example number 2 says identifying symmetry in a shape and its transformation image. So it says draw the image of this parallelogram after a translation of 2 squares down and 1 square to the right. Write the coordinates of each vertex and its image and describe any symmetry that results. Okay, 2 down, 1 right. So I'm going to start A. 2 down, 1 right. Now, this is where my new A is going to be. 2 down, 1 right. This is where my new B is going to be. 2 down, 1 right. My new C. 2 down and a right. There's my D. I'm going to take a straight edge just because it's so easy. Make it red because my dots are red. So my new shape is there, 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 and there. Okay. Describe any symmetry. Do you see any line symmetry? Is there a line that I could draw? Can I draw it there, or I could draw it there, that I can flip this image onto itself? And I would say no, because if I flipped this image onto itself with this line, I'll show you what it would look like. Get a green line, okay. If I had a line of symmetry right here, right, oh, let me just move that to where I wanted it to be. Not there, but here. That line of symmetry right there. Okay. So if I had that line of symmetry there, is my line still green? It is. This would actually end up here, okay? This would end up there. And see how the green shape would look if I reflected it. The green shape's not the red shape. So it doesn't have any line symmetry. Let's get rid of that now. Get rid of you. Oops. Where'd you go? Oh boy. There we go. You go away, and you go away. Okay, so I would say no to line symmetry. Now about rotational symmetry, do you think that if I stuck, what about right here? Do you think if I stuck a point right here and turned it on that point? So let's go, I want to draw it so I can show you reflected. So remember, tracing or drawing it and then reflecting it on itself is a strategy that I have to use because I'm not that good at visualizing this stuff. I need to get rid of that green line. Let's see if I can. Nope. Let's see. Green line, we could. No. There we go. Green line needs to go away. All right. Now that dot needs to stay there because that's going to be my rotational dot. Let me move up a little. There we go. Green line, go away. Now I'm going to make a shape out of the black stuff. I don't want any of the red. Let's see if I grouped it together. Did I do it? Oh, I didn't. Burn it. I got some of the red. I don't want some of the red. Let's undo them. There we go. Okay. Let's see. Red, move out of the way for a second. Oh boy, I should have had this organized first. Okay, I want you guys to be in a group. Red, I'm going to move you back. Because I want to see, can I rotate the black shape onto the red shape? Okay, now I'm not gonna be able to rotate it perfectly because that's not how the smart rotating works, but I want to keep that dot right where it is. So if I rotate it and then I slide that dot to where it is, all I wanted to do is show you that if I take the shape and I rotate it 180 degrees, it looks like the red one, but it's not on top of the red one. Okay, so remember, this was the way it stay there, red. This is the way it was right there. Okay, that's my order, my point of symmetry. And then if I wish I could, but this software won't let me, but if I rotate it and then the dot stayed where it is, it doesn't have rotational symmetry. So I would say that no, there is no symmetry. No line symmetry and no rotational symmetry. Okay, so what about this example here? It says, draw the image of this polygon many-sided shape. After a translation of 2 squares down, write the coordinates of each vertex on its image and describe any symmetry that results. Okay, I wouldn't bother with any of this. What they're doing is 2 squares down. They want you to do ordered pairs. I'm not going to do that. That takes too long. It's way easier just to count squares. Okay? So our translation, what we're moving is 2 squares down. Go to every single dot and go 2 down. 2 down. Count 2 down. We don't need to start fiddling around with numbers because you may make a mistake and it's just as easy to count squares. Okay, I need my line tool. I'm going to connect my points. Please do that as well to make your new shape. Okay. And then because I'm going to be a little more proactive, I'm going to make it a shape. Group it. Yay, there we go. See, I grouped it. Okay. So hopefully you can see immediately, well, yeah, there's line symmetry. They're mirror images of itself. Okay, so it says use a mirror to check for line symmetry. I don't got to do that. Look at, you can just visualize a line. Let's go red, and here's my line of symmetry right there. It's exactly the same on either side. This dot Z, 2 over. This dot U, or sorry, this dot Z, 1 away from the red line. U is 2 away. V is 2 away. W is 1 away. So the the shape has a horizontal line of symmetry, I wonder what they mean here, has one line of symmetry, doesn't have more than one, because it's not like you can draw a line here and this shape is exactly this green one. It has one line of symmetry, and draw on any label any lines of symmetry you have. I would say this L1 is the only line of symmetry we have. Okay, rotational symmetry. Let's think about that. So remember that I need this to turn and be exactly this shape. And just me looking at it, I think it's got one. I think it's got 180 degrees if I stick a point here. So let me show you that. I'm going to get rid of my line. I'm going to move this just so I can make a new copy that I can turn. What do you think? Orange? Sure. So 1, 2, 3, 4, 5, 6. I'm going to make a shape by joining them. Okay. Now, that's my original. It's in orange. This is my reflection. Remember how I translated it 2 squares down? And I think that if I stick a dot, oh, green, get out of the way just for one more second because I need that dot. I need to show you that point of symmetry. It's right here. Okay, right there. And then I'm going to join it. Okay, and you go back there. Okay, can you visualize it? So this, if I wish I could turn it on that point, but what I'm going to do is I'm going to rotate it 180 degrees and I'm going to stick that point exactly in the middle of YX, because if the software let me do it, I wish I could keep that spot still and turn it. But as it is, if I turn it and then put that dot there, look at how it exactly covers that green one. So if I put a point of symmetry right there and rotate it 180 degrees clockwise or counterclockwise, I have exactly the same shape. So does this shape have rotational symmetry? Yes, it does, with 180 degrees, either clockwise or counterclockwise, and my point is right there. Again, let's ignore this stuff. Draw the image of this polygon after a reflection in the line along QR. Okay, here's QR. Here's my line of symmetry. I would strongly suggest make yourself a nice line of symmetry. Okay, and I'm even going to make that nicer to look at. I don't like black. That doesn't help my eyes. Something bright does, red. There's my line of symmetry. Okay, and then look at, it's difficult to see, but look at my shape. It's kind of looks like half a T, doesn't it? So it says write the coordinates of each. You don't need to do that. Just let's trace it, or let's reflect it. So draw the image of this polygon after reflection, write the coordinates, and describe the symmetry. Okay, Q is exactly on the line of symmetry, so I can't count squares because Q is exactly on it. But P is 2 away, so count 2 over, and that's my new P. T is 1 away, count 1 over, that's my new T. U is 2 away, so count 2 over. Okay. S, 1 over, so go 1 over, and then R is exactly on it, so you can't reflect that on the line. It's sitting on the line. Okay, so red line. I'm going to go there. I need a solid. You go away, silly line. I don't want you. I want a solid line. And I want it red. Okay, here we go. So that's 2 squares. It's 1 square, 3, and then over. And that is the image after the reflection in the line QR. Any symmetry that results, it's got this vertical line of symmetry. And draw and label the reflected image. Well, that's Q. I'd have to label that P. Look at how they've got a P tick. I wasn't going to talk about that, but I will since they've shown it here. You put a tick when this is the original and this is where you moved it. Okay, it's called prime. So that's P prime. Q prime you could label right there. This is T. The little tick indicates that it had an original spot and it's since been moved. And that's it. I do not think you'll have any problems with symmetry. It's pretty easy just to look at and tell visually. And that's chapter 7. You're done.